Hi everyone, this presentation covers the differences between focus areas and concentrations and briefly introduces you to each for the electrical engineering degree. We will talk a lot about EE electives, also called EE technical electives, which are how EE students form focus areas. You'll find places or boxes for EE electives on your flowcharts and in your online U Achieve degree audit report, which you can run anytime in My Michigan Tech. This slide shows examples from the flowchart and from the degree audit PDF form for the EE electives area. First, know that your degree requirements are defined by major, concentration, if any, and catalog year. Your catalog year is the academic year you began at Tech and is noted as 2021-08, for example, if you began in fall of 2021. The number of EE elective credits required depends on the major with or without a concentration and the catalog year you are following. Focus areas and concentrations are two different educational pursuits. A concentration is listed on the diploma. A focus area is not. A concentration is a prescribed set of coursework giving the student knowledge and skills in a particular area. With the EE degree, we offer two concentrations from the ECE focus areas, photonics and electric power engineering, and three concentrations that provide knowledge outside the ECE field and can be directly related to the career, biomedical applications, environmental applications, and enterprise. Specific courses and electives define a concentration. The major with a concentration is the same total number of credits, and there is a unique degree audit form and flowchart for the concentration. Focus areas are areas of specialization within the ECE field. Elective courses offered by the ECE department fall into one or more focus areas or areas of interest. This is a free-form way to select courses and focus areas that you'd like to graduate with. Nothing is declared, and you can mix and match the elective courses as you like. So, what is the difference between a concentration and a minor? For a concentration, the coursework is related to the major and is included in the degree requirements within the 128 academic credits of the degree. The requirements of a concentration are defined by the department which offers the degree. A minor is typically from a different department and related to a different subject. A minor has its own degree audit form defining the requirements for the minor. Minor courses may double count with the major as appropriate, such as some math courses or general education Haas courses. A minor typically adds credits over the 128 credits, and so you might add a semester or plan summer classes if you pursue a minor. Concentrations and minors are optional and not required to earn your EE degree. Focus areas are a way to specialize in an ECE area of specialization by taking courses that you choose across the different focus areas. This slide shows a sample list of EE elective courses listed by focus area. To find this, go to the ECE advising page and click the link to Electrical Engineering Advising page. There are hard copies in the ECE Advising Office, 131 ERG. This slide shows snippets of the EE electives area as examples of what you'd see in your degree audit report before you've taken any EE elective courses and after you've registered in or completed some. The ECE department has made a change to the degree requirements beginning fall of 2022. EE 3261 Control Systems and EE 4250 Modern Communication Systems are no longer required courses but may be taken as electives. Students using catalog years prior to 2022-08 may substitute an additional EE elective course of the same or higher level if they wish. Know that EE elective courses are offered once per academic year, either in fall or in spring, not both. Therefore, it is best to plan ahead to take the courses you prefer and ensure you have the prerequisite courses completed on time. The more courses you take from one focus area, the stronger your skills and the more in-depth your knowledge will be in that area. It is good to have at least one focus area for your resume and job hunting. Following the flowchart, EE electives are typically taken in the senior year, but there are some electives that may be taken in the spring of sophomore year or junior year if you have completed the prerequisite courses. This next set of slides is an introduction to each focus area. Included is a chart that suggests when you may take elective courses for a focus area. Some prerequisite courses are included so you can plan to get them on time. At the bottom left is a list of job types for each focus area, and to the right a list of faculty who teach and research in that area. These slides are available in the Advising Office and the EE Advising webpage for future reference. If you are curious about an area, the faculty are a great resource for finding out details on the courses they teach and on careers in a focus area. The Communication Focus Area deals with the transmission of information, including voice, data, location, and sensor networks. Communication engineers design, develop, and integrate and test network management systems for specific applications, such as an in-vehicle communication network, or a wireless sensor network in an assisted living facility, which can integrate a variety of environmental and medical sensors. With the Internet of Things, businesses can connect, manage, and analyze data from hundreds or even thousands of devices. Take Modern Communication Systems, EE 4250, if you are interested in the communication area or areas closely related. Some of the challenges in communications that the engineer will help solve include security and privacy, network performance, and interference from the environment. The engineer who specializes in control systems will design and develop electrical systems that control physical devices. An example of a simple feedback control system is cruise control on an automobile. A sensor measures vehicle speed, which is input to the control system and compared to the command speed set by the driver. The control system adjusts the engine drive force to obtain the desired speed. Autopilot on a jet is a complicated control system which involves controlling flight, speed, direction, and altitude over time and location. Sensors on physical devices and in the environment communicate with control systems over the wide world web, creating the Internet of Things. Other applications of control systems include controlling temperature and ventilation in a hospital, robotics and automation in manufacturing, and controlling precise temperatures of specialty materials during production. Biorobotics is being used in helping surgeons be more precise in a procedure and less invasive. Mathematics skills go well with the controls area and are an important prerequisite to all your ECE courses. Invest a lot of time in developing your math skills. When you fly in an airplane, cruise in a self-driving car, or ride a roller coaster, you are trusting the design work of the engineers. EE 3261 Control Systems is the kickoff course for this area and is a required course for robotics engineers. Controls engineers are in high demand. One of our faculty designed missile guidance systems for the Navy, missiles that seek other missiles to hit them and stop them from their target. Dr. Boss has been leading the AutoDrive Challenge, where they are converting a Chevy Bolt into a completely autonomous vehicle for a competition amongst 8 universities. In the computer systems area, electrical engineers work in the design of hardware, power, and communication components, such as those involved with embedded systems. Embedded processors control sensors, displays, and other I/O devices. Applications range from a simple home thermostat to sophisticated metering devices, and from toys such as a remotely controlled drone to aerospace controls. If you enjoy programming in the Digital Logic course, you may be interested in this focus area. The core required course for electrical engineers is EE 3171, Microcontroller Applications for Cyber-Physical Systems, which has Digital Logic as its prerequisite. The computer engineering counterpart to EE 3171 is EE 3173, Hardware-Software Integration. EMAG is a 4-letter word, kind of like snow. It can be difficult to work with, interferes with activity, but you can take it and use it and do great things with it. EE 3140, Electromagnetics, is required for all electrical engineers. Electromagnetics provides the foundation for much of what we do. It is the manipulation of the laws of electromagnetism to devise tools for use by humankind. Electromagnetics deals with the relationship of electricity and magnetism, which is involved with virtually every electrical system, as electromagnetic fields influence electromechanic, electronic, and photonic systems. The transmission of signals or of power cannot be done without the magnetic and electric fields. Therefore, a good understanding of electromagnetics is needed in signal processing and power transmission applications. Students who wish to further study electromagnetics could end up designing an array of antennas to communicate with satellites, or fast trains supported by a magnetic field, or MRI technology. Among the job types listed here, the last one is elusive, so you can't see it. It is the development of cloaking methods. In her research here at Michigan Tech, Dr. Elena Samuchkina has developed 2 successful methods of invisibility. She figured out how to bend light around a tiny object or particle so that it cannot be seen. The work of the electrical and computer engineers in electronics is probably the most visible focus area in ECE, as we see and use electronic devices and systems every day. Electronics engineers design electronic devices and their components using mathematics, physics, and circuit analysis skills. They design, develop, and test electrical equipment such as electric motors, power generators, and radar and navigation systems. They work with all industries and most products, ranging from tiny biomedical devices to robotic equipment to aerospace technology. Electrical and computer engineers are educated in the basics of electronics in EE 3131, a required course. EE 3131 is one of the prerequisite courses for your engineering design requirement, either senior design or 4000 level enterprise work. Photonics involves the control of photons in generating and harnessing light for use in sensing, communications, lasers, instrumentation, and related hardware and electronics. Photonics majors may embark in careers designing robotic vision systems, laser technologies, satellite design, remote sensing, or fiber optics. Our own Professor Mike Roggeman helped with the design of the satellites that are out there working in outer space. Like in the movies when you see the president and generals hovered around a monitor, our government is getting intelligence from those satellites. Students can take photonics courses as EE elective credit or towards the concentration requirements. If you are interested in some hands-on learning in photonics and optics, or finding out if photonics is for you, you could join the International Society for Optics and Photonics student organization, where you can be involved with photonics activities and research. They have a lab in the sub-basement, room 24. The best time to take Introduction to Photonics, EE 2190, is in the spring semester of the second year. Students who focus in the power and energy area could work with controlling power for hybrid electric vehicles, power for electronics, or developing new technologies for the power grid, such as designing microgrids so that smaller areas are affected when an outage occurs, and developing smart grids, which are self-monitoring and self-recovering. Electric power engineers are integrated alternative energy sources into our power grid and protecting the grid from cyber attacks. They are designing the next generations of hybrid and fully electric vehicles. We have a very strong power program here, as you can see by the number of faculty who teach and research in this area. Also, after graduation, we offer an online master's in power. The IEEE Signal Processing Society defines signal processing as the science behind our digital life. Signal processing is the analysis, interpretation, and manipulation of sound, radar, image, video digital data, and other signals. The DSP engineer develops techniques for improving the accuracy and reliability of digital communications. An example of a signal processing application is a radar detection system. It detects an object and sends back a signal containing information that there is an object out there. Using pattern classification, it can tell us if it is a bird, a plane, or a drone. Signal processing resides on the outer edges of the Internet of Things, where sensors are collecting data. Data gathered from sensors is compressed, transmitted, and received and processed for use in analysis or control. Signal processing is also core in medical imaging, mobile communication, the audio and entertainment world, and biomedical signal analysis. With all of these choices, don't you just want to take them all? So how will you narrow them down and decide the right EE elective courses for you? As you are taking the junior level courses, ask your instructors about the elective courses and focus areas that they lead to. Which focus areas does this course prepare us for? Or what job types in industry? Take a co-op or internship and work with professional engineers where you'll learn about one or more focus areas. Talk with people from industry at career center events and industry days. Perhaps you could join an enterprise project team that exposes you to an area you are curious about. Join a student professional organization such as IEEE or SPIE, or perhaps get involved in undergraduate research with a professor. Don't be afraid to get to know your professors who are experts in their areas of specialization. Our faculty listing is on the ECE department website, where you can find office numbers, email addresses, their areas of interest, and access to their webpage. Now we'll review the 5 concentrations, and we'll mention a few things to know for registration. It is good to plan courses out for the next several semesters, especially if you are considering a concentration. Feel free to meet with your academic advisor if you'd like help with planning. These concentration slides are posted in the advising office and website. This slide pertains to the photonics concentration, which includes courses from the photonics focus area. In spring of second year or spring of third year, take EE 2190 Introduction to Photonics and postpone EE 3120 Electric Energy Systems. EE 3120 is not required if you pursue the concentration in photonics and can be postponed to the third year without getting off track. EE 3140 Electromagnetics is an important co-requisite or prerequisite for most photonics courses. Take EE 3190 Optical Sensing and Imaging in the fall of the third year, and EE 3290 Photonic Material, Devices, and Applications in the spring of third year. Take EE 4490 Laser Systems in the fall of the last year. Students also choose 2 photonics-related elective courses with this concentration. Electrical engineering majors who are considering the biomedical applications concentration take Anatomy and Physiology 1 and Cellular and Molecular Biology in fall, then take Anatomy and Physiology 2 in the spring. It is possible to complete the concentration by beginning in the third year if you decide after the first year. Choose either Biomechanics 1 or Biomaterials 1, depending on your interest, and for a mini focus area, you could take Biomechanics 2 or Biomaterials 2 for the elective course, or choose another course from the Biomedical Applications electives list. Take Bioinstrumentation with a lab in the spring of third year or fourth year. In this course, you'll learn about measuring biomedical data such as vital signs. With the Biomedical Applications concentration, the graduate is prepared to work as an electrical engineer in the biomedical industry, designing medical devices such as electronic implants or biorobotic devices. You are not limited to the biomedical industry for careers. You can choose 6 credits or maybe more with which you can take courses from other focus areas. For example, you could focus in electronics, photonics, or signal processing with this concentration. To begin taking classes for the Environmental Applications concentration, take CEE 3501 Environmental Engineering Fundamentals in the fall of third year, and CEE 3502 Environmental Monitoring and Measurement Analysis in spring of third year. Choose one of 2 remote sensing sequences, 2 courses each, which will be taken in third and or fourth year. One is EE 4252 Digital Signal Processing and its Applications, plus GE 4250 Fundamentals of Remote Sensing. And the other sequence you may choose is EE 2190 Introduction to Photonics and EE 3190 Optical Sensing and Imaging. Take 2 Environmental Engineering Quality elective courses. These electives include Drinking Water Treatment Principles and Design, Air Quality Engineering and Science, and Surface Water Quality Engineering, among others. With the Environmental Applications concentration, the graduate is better prepared to work in environmental companies and applications as an electrical engineer, perhaps designing systems which measure and monitor pollution in air or water. The EE degree with this concentration includes 6 credits minimum, which you will take courses from the ECE focus areas, such as power and energy, signal processing, and or photonics, so you are not limited to careers with environmental companies. The first course to kick off the electric power engineering concentration is EE 3120 Electric Energy Systems, and can be taken in the spring of second year or the fall or spring of third year. In the fourth year, power concentration students will take Power Analysis 1 in fall and Power Analysis 2 in spring, along with EE 4226, the Power Engineering Laboratory. Choose 2 electives from the power focus area. The student with this concentration is well prepared to work in the power industry with power grid technology, power electronics and machinery, and power for hybrid or electric vehicles. The power concentration includes 3 credits from another focus area, minimally. The enterprise concentration might be interesting to you if you decide to join an enterprise and wish to take additional courses which supplement the enterprise project work with business and leadership skills. A minimum of 4 semesters of project work at the junior and senior level is required, which would also satisfy your engineering design requirement. You may join a project team sooner than that if you'd like. The 2 required supplemental courses are Teaming in Enterprise, taken in the fall of 2nd or 3rd year, and Communication Contexts, taken in the spring of 2nd or 3rd year. Choose 3 credits of enterprise modules, which are lecture-based 1 or 2 credit courses to add business-related knowledge and leadership skills. EE majors choose 12 credits of EE elective coursework minimally from the various focus areas with this concentration. A concentration adds no extra credits and may be done within the 128 credits of the major. If you decide to add a concentration, submit a request in My Michigan Tech Current Students tab under Academic Programs and Advisors. Your degree audit report will then reflect the requirements for your major with the concentration. This is also where you can request to add a minor, double major, or change your major. This concludes our presentation on focus areas and concentrations with the electrical engineering degree.